how we are going to evaluate the tracing. First of all, the easiest one, and basically this is how you start by looking at the chart and looking at the rhythmicity of the heart rate. When we are talking about rhythmicity of the heart rate, we have to consider the QRS complexes, the distance between the QRS complexes. But you don't need to be very accurate, so you don't need to count in millimeters. By looking at your naked eye, you can say it's rhythmic or not. This is the first one, so rhythmicity. As you see on this ECG, this is rhythmic. Okay, very well. Next one, about the rhythmicity, we can calculate the heart rate. Okay, the ECG basically is very good to calculate the heart rate, but much easier to, for example, feel the pulse of the patient. And but there are several ways to detect the heart rate. First of all, you know that then on the ECG tracing, the speed of the chart, that's about 25 millimeter per second. Okay, millimeter per second. Okay, it's meaning that you do have at least 5 small or big square between this 1 second interval. Very good. So this is 1 second. Okay. Now, the next one, there is a possibility. If we do have a QRS complex that falls exactly in every second, okay, if you do have a QRS complex here and here, for sure it means, because you have to calculate the heart rate per minute, beat per minute, it meaning that you do have exactly 60 beats per minute. So if I do have exactly five squares per between 2 hours, it means that the rate is exactly 60 bit per minute. Okay. Now, if you calculate that, if we had about every, for example, every square the RR interval is coming, that meaning that you do have at least 300 bits per minute. So if I do have one square between the RRs, that represents 300 per minute. Okay, very simple one. If I do have two squares, this means 150. This is what was on the video as well, so it's easy to follow it. But let's see. 3 means exactly 1/3 of the 300, so this means 300, 100 bit per minute. And if I do have 4, that meaning that we do have exactly half than a 2, so it's 75 bits per minute. Now, you know that the normal uh, heart rate exactly falls between 5 and 3. So these are the normal. So it's meaning the normal one goes from 60 to 100. That's a normal interval for the heart rate. Good. Now, based on this, the equation or the calculation is simple one. What you have to do, the heart rate could be determined if you divide the 300 by the number of the big square. Okay, that, for example, in this case, if you follow it, 1, 2, 3, well, 1, 2, 3, 4, 5. That's between 4.5. Okay, so it's meaning between 5 and 4. What does it mean? It means that if we had 5, that bit should be 60, but because it's a little bit more than 4, so the rate is between 60 and 75. Now you can guess it. If it's closer to, for example, the 5 square, you can go closer to 60. If it's closer to the 4, goes closer to 75. In our case, for example, 1, 2, 3, 4, almost 5. So you can say that's around, for example, 65 the bits. Okay, This is how you guess it. Next one, that's another possibility to calculate the heart rate. If you count an interval, and that can be used, for example, in the situation when we do have arrhythmia. So let's count how many seconds we have here, and that can be used, for example, for counting the RRs. Okay, so we have 1, 2, 3, 4, 5, 6. That's very good because we want to know how many beats we have in 60 seconds or 1 minute, and exactly 6 seconds. 6 seconds means we have to multiply by 10. So 1, 2, 3, 4, 5, 6, 7. So the rate exactly 7 times 10, 70 beat per minute. All right. This can be used in any case. If it's arrhythmic or rhythmic, doesn't matter. It can be used. Good. Now, another thing that you should know right now, by looking at that, do we have P waves or not? But this goes for the next seminar, but it's very good to know it, that every P precedes the R, so it's meaning, and the rate is in a normal range, and the P shape and the duration and all time and amplitude is good. So that's a sinus rhythm for sure, and there's a normal sinus rhythm. The next one, the electrical axis. Why do we need the electric axis? Because we want to use to make a diagnosis out of it. For sure, normally the axis is saying that what could be the anatomical axis. Its normal situation is proportional to each other. However, there are some abnormality. When we do have an extreme deviation, that is called a pathological deviation, that some other abnormality can cause it. That's, for example, conduction problem, infarction. A lot of things can cause this one, or an abnormal impulse formation center, and so on and so on. So this is why we should do the axis as well in a situation. How do we do the axis? There are several ways. One is the best one, the quadratic approach. What they are using for a quadratic approach, okay? This is the quadrant, so we do have the all 360 degrees, and there are two leads that relatively can divide this all circle, okay, so the AVF, to two different or four different quadrants. Okay. Lead number one will tell us whether we are on the left side. I would say this is a left side. Okay. That's a left. And that's the right. All right. This is a right side. If lead number one is positive, we are located on the left side in a case of positivity. If we do have lead number one negative, we are on the right side. So immediately you can say whether the axis is on the left or on the right side. Looking at lead number one, that's a positive. So you know that we are on the left side. Good, very good. Now let's looking at AVF. Okay, AVF will tell you very simple and in a similar way whether you are at the bottom or you are on the top. Okay, let's look at AVF. AVF in this situation is positive, so where the AVF is positive, it's right here at the bottom. And AVF is negative all the way here. Okay, this is a two different situation for AVF. Because we do have a positivity of AVF and positivity lead number one, we have to choose the common part of it. And what is a common part? This quadrant, and this quadrant that we have, that's a normal. Normal means the axis exactly between 0 and 90. That's the normal interval, and this is what you have right here. Okay, that's a normal interval. If lead number one is positive, but AVF is negative, you are here on the top. And that's sometimes can be normal, but sometimes is not. Okay, you learn it that let's see, the cutoff value is exactly at AVL, and AVL represents the minus 30 degrees, okay, minus 30 degrees. And if you are here, that's extreme deviation. And if you are here, that can be normal, but can be deviated as well. This is what is called the left deviation. Which lead will tell us whether we are here or here? Very simple one. Lead number 2. Because lead number 2 exactly perpendicular to minus 30 AVL. So if lead number 2 is positive, you are here. If it's negative, we are here. Now, on the right side, there is another lead that we can use it. Maybe I'm using a different color. Let's use this one. Okay, AVR is minus 150 or, okay, right here. And exactly perpendicular to lead number 3. Lead number 3 is 120, okay, 120. All right. So if AVR is positive, we are here, okay? We are here. It's up to this point is my, oops, and this is exactly minus 60. It's always coming up this, okay? Now, and that's positive. If it's negative, we are here. So if we do have a right deviation when we are falling around here, that means AVR is negative and lead number 1 is negative. Or 1 positive, 2 negative to see whether we are here or we are there, that we can use AVR to differentiate it. But in our case, what we are seeing here, that's exactly meaning that we do have a normal axis, and that's axis, what can be the axis? Let's see. First of all, by looking at lead number 1, that's positive, AVF is positive, that's okay. Now, it meaning only that we are somewhere here. Let's look at lead number 3. Lead number 3, that's very good because it's perpendicular to 30 and exactly meaning that it's a very small, okay? It's meaning that exactly perpendicular. So that axis is around 30. That's another way that you can get to this point as well by looking at the size of the QRS complexes. Okay, let's look at by that way. First of all, let's choose which is the biggest one. Okay, 1 and 2 is about the same. What does it mean? Lead number 1 and lead number 2 is the same. When can it be? If the axis exactly located in the middle. In that case, lead number 1 and lead number 2 should be the same. So again, the axis is 30 degrees. I hope you understood. If you do have any question, you can ask it right now. If not, we are moving further. It's okay? Good. All right. Let's see the next one. The next one is 102. Anybody is here with 102? Hmm? Nobody. Okay. I will ask similarly. Rhythmic or not? This is the first question. Yes, it is rhythmic. Good. Next one. What is a heart rate? Okay, let's calculate how many square we have between 2 hours. 1, 2, 3, 4, 5. Again, very close to 75. I would say 72, doesn't matter. Okay, or 75. You can say 75. Good. Next one. Yes, we do have P waves in front of every QRS complexes, so you can say that's a sinus rhythm. And because the rate is normal, so that's a normal sinus rhythm. Axis. Again, by quadratic approach, let's look at lead number 1 and AVF. Okay, this is positive, so that's normal. So it's ranging between 0 and 90 degrees. Good. However, let's look at lead number 1. It's almost equiphasic. It's meaning it's close to or plus 90 or minus 90, but you do see that positivity AVF, so it has to be here. It's meaning the degree is 90 degrees. However, let's look at, if you see that this is a little bit more positive, you can count that a little bit less than 90. So you can say, for example, the degree is 80 degrees. Okay. Now, very similarly, let's look at lead number 2 and lead number 3. Okay, lead number 2 is located, I'm changing the color, located at 60. Okay, and another one, lead number 3 is 120. Okay, 120, and this is 60. Good. If we had AVF, it's meaning that the R in lead number 2 and in 3 should be equal. However, as you do see, lead number 3 is a little bit smaller one. It's meaning that we are a little bit closer to lead number 2. So again, we detected 80. All right, good. Next one, 103. Who has 103? Guys, nobody's here. Uh, Luyain. I don't know whether I pronounced or not.
Where can we see the name list? Because what we got was just an example of the name list. It wasn't our names.
But after I send it again,
Oh, I don't think I got it.
okay, and that way I can drop it into the chat. Okay, that would be the best one. Okay, I'm closing it. Okay, very similarly, rhythmicity. Is it rhythmic? Yes. Okay, rate is around, as you see here, is less than 3, so it's tachycardic. It's over 100. It can be around 120, for example. So that's tachycardia. We do have P waves. Yes, we do have P waves, so it can be sinus tachycardia. Good. Next one, we have to calculate the axis. Okay, again, the quadratic approach. Let's look at lead number 1, positive. Let's look at AVF, positive. So that's normal, period. So that's meaning between 0 and 90. After, you can use the which one is equiphasic approach. Okay, but none of them is equiphasic. The smallest one may be AVL, but it is still positive. So what can we use? We can use, let's see, which is the largest one, which is the biggest one. Okay, which is the biggest one? Biggest one is lead number 2. What does it mean? Lead number 2 is meaning 60, yes? So the axis is parallel to 60. Okay, so the axis could be around 60. Okay, let's look at let's look at lead number 1 and compare the size to lead number 1 and lead number 3. Okay, these two that you should compare. Which is a bigger one? Lead number 1 is a bigger one. So it's meaning that the axis should be a little bit closer to lead number 1. So the axis should be 50. Okay, so it's still normal, doesn't matter. So maybe they are not asking you what the axis is, and especially the gadget will write you immediately the data, so you don't need to hesitate, you don't need to calculate the axis. But here for the midterm, you have to. Okay, 104, I think the owner of 104 is here. Do you want to share your screen or I do it?
Uh, if you can do it. I don't have the
I do
photo.
it. Okay, I do it.
Yeah.
Don't worry. So let's go step by step.
So there are four boxes.
Okay, so rhythmic, first of all,
Yeah,
rhythmicity,
this
all
is
right?
rhythmic. Yeah.
Rhythmic, okay, we do have 4 boxes between the R, so the
Uh-huh.
rate is 75.
75.
Good, so it's normal, that's it, normal. Next one, if we do have P waves, yes, nice P waves, so that's meaning that we do have sinus rhythm, period. Good. Next one, the axis.
So LVF is positive.
AVF is positive, and lead number
That
1 is
means 0 degree.
0 degrees. What does it mean when it's 0 degrees? exactly perpendicular to 0. It can be 90 or minus 90, but because AVF is positive, you are here. It's plus 90. Yes?
Yeah.
Okay. All right. Oops, wait a minute, wait a minute. I want to delete all. Good. And now move on. 105 is not here. Okay. Let's do together. First of all, it's rhythmic?
Yeah,
No,
sorry,
it's
Professor,
arrhythmic.
I'm here.
Okay, so it's yours. Okay, good. Do it.
All right. So just by looking at the graph, we can say that we can see PQRS waves. So it is rhythmic, like sinus rhythm is normal, and also the RR interval are consistently spaced. So
I
the
don't
rhythm is
think
close.
so. You are looking at 105.
Yeah, 105.
Okay, look at this distance and compare to this distance or compare to this distance or this one is not rhythmic. By looking at immediately, you can see this is arrhythmic for sure. This is arrhythmic. All right, it's not rhythmic. It's arrhythmic.
Okay.
Okay, because different. As another thing that we do have P waves. Yes, we do have P waves,
Mhm.
but this P is not the same. If you get a little bit closer, you will see that these P's are not the same. Okay, but in the next time, you will figure out what can it be. Okay, now because we have arrhythmia, we have to calculate the average heart rate. How do we calculate it? By counting a longer interval. How long we can have 1, 2, 3, 4. Yes, 1, 2, 3, 4. So 4 seconds we do have. 4 seconds means we have to multiply the number of the R by 15. Okay. 1, 2, 3, 4, 5, 6. Okay. That equal with 90. So this is 90 beats per minute. It's still normal. Okay. It's still normal. Next one, the axis.
Okay. So we can see that EVF is positive, and also the wave
EVF, what you are looking at? What you are looking at?
QRS. It is positive, right?
No, it's not positive because you do have a small positivity and a huge negativity. And the sum of it is negative. So
Okay.
AVF is negative for sure. Okay?
Okay.
Lead number one, however, is positive because you do have much more positivity and there is no negativity. So what we do have here, basically, that lead number one is positive. Okay, so we are on the left side. However, AVF is negative. It's meaning we are here in this quadrant. This is not a normal axis. Okay, it's not normal. Next one that we have to figure out whether this is exactly, this is minus 30 because this minus 30 is AVL, okay? This is a differences between the extreme deviation or only the left deviation. Let's look at which is perpendicular to AVL. Is perpendicular lead number 2. We have to look at lead number 2. Is positive or negative? Because if 2 is positive, we are here. We do have only left deviation. And yes, it's about positive, yes? It's more positive than negative. So it's meaning that axis can be around minus 20. Okay?
Thank you.
You're right. Let's move on. 106.
Yes.
Nobody? Okay, good.
Yeah. Yeah. Okay, so 106. Obviously, this is sort of arrhythmic. It's not regular intervals between the R intervals. There's no sinus rhythm because I can't see a P wave on any of the first three Einthoven leads. The heart rate is irregular, but I estimated it at around 150 beats per minute.
Okay, so we have to count 3 seconds and you have to multiply 1, 2, 3, 4, 5. Well, it looks like it's 100, but it's can be a little bit more than 100. Okay, it's depending on where you are looking at and which part you're looking at. It's okay. It's 100. It's tachycardic. Okay, go on.
In terms of the heart axis, we see that lead 3 seems to be the one with the lowest amplitude QRS complex. So if we take
Very good, very good, very good. It's meaning that is perpendicular to lead number 3. Yes.
so that would be the AVR more or less, which would be I think
No,
about plus
or
30 degrees.
AVR. Okay, AVR or this. Okay, so which one? AVR is
Plus 30 degrees.
exactly negative. So this is why you are choosing 30 degrees. Correct.
Yeah.
Very good. Okay, good. Thank you. Yes. What else?
Then in terms of like the causation, I'm sort of going on a bit of a long shot here based on the lecture that we had this morning.
No.
But in lead V1, I see in some places what looks almost like the inferior retrograde P wave that we were discussing in the lecture, which they said was indicative of an AV node reentrant tachycardia. But that's
okay. It's an atrial tachycardia or paroxysmal atrial tachycardia because you do have different P waves. It's not a retrograde. And if you had a AV nodal tachycardia, for example, that you do see some retrograde P waves, that should be rhythmic, but this is arrhythmic. Okay, so this is why this is we will learn it on the next seminar, all right? So don't rush.
But is this then atrial fibrillation? Is that what you
No,
could
no,
call
no,
this?
no, 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 no. Again, this is the next seminar. Atrial fibrillation means arrhythmia without P wave. There is no P wave. I will show you that tracing, but again, that's the next week. All right?
Okay. All
Step
right.
by step, as an old bull says. Okay?
Sounds good. Thank you.
Okay, you're welcome. All right, let's see number 107. Now that's an atrial fibrillation. See, that's an atrial fibrillation because it's completely arrhythmic. And sometimes you can see the undulating baseline. It's very fast, the rate. If you can't hear that very, very fast is more than 300. Okay, so that's atrial fibrillation. But the or let's say the easiest one to recognize in atrial fibrillation, arrhythmia absoluta, because if you are looking at, there is no rhythmicity at all. So arrhythmia absoluta, no P wave, atrial fibrillation immediately, but it's the next week. Now, who has 107?
Yes, that's me.
Okay, so we already said this is arrhythmic. Fine, good. Now let's see the rate.
Okay, so this is not the rhythmic, so I calculate the average, and there is a 5 second in this graph, and in 5 seconds there is a seven times of heartbeat, so I calculated, and the heart rate should be around 84.
Okay, great. 84, that's normal, still normal. Okay, go on.
And the lead number 1 and AVF are both positive, so heart axis should be positive, and they
Okay.
should be normal.
Yes, that should be normal. And again, that's a low voltage, so it's a very low, the R. And if you're comparing the R, for example, in lead number 1 and in lead number 3, it's about the same. So I would say the axis is around 60. Okay?
Okay.
Good. Very good. All right. Let's move on. 108.
Yes.
So
we can see this is a arrhythmic ECG, and I counted 8 heartbeats in 6 seconds. So that would be around 80 beats per minute. And for the electrical axis, first we can see that lead 1 and AVF is both positive. Then lead 1 has the lowest amplitude.
And let's
lead
see that
2
by
has
the 2 and 3. See 2 and 3, compare 2 and 3.
So lead 2 has higher amplitude.
It's very important because if you are looking at this is AVF, relatively that's the biggest one, almost AVF. Okay, and lead number 3 and lead number 2 exactly falls, AVF falls in the middle. if you had a 90, that's lead number 2 and lead number 3 should be equal, okay? However, lead number 2 is bigger than lead number 3. This is why you are getting a little bit closer to lead number 2, okay? So it's meaning the axis is around 80 degrees. This is a 10 degrees plus and minus. This is what we're applying. It's a number of rules, okay?
Okay, thank you.
You're welcome. All right. Move on. Let's see. 109.
That's me.
Good.
So first of all, is regular rhythm because there are four big squares between each R wave, around 75 beats per minute.
You are looking at the same tracing that I'm looking at.
Oh, yeah, is irregular.
Exactly. That's irregular, yes. And this is why it's difficult to calculate the rate because it's difficult to see where these 5 squares are coming. Maybe I try to interpret it. Okay, 1, 2, 3. Okay, that should be 5. 1, 2, 3, 1, 5. Okay, so the distance between is exactly this. Okay, so it's meaning that 1 second, that 1, 2, 3, 4, 5, that's a 2 second, 1, 2, 3, 4, 5, 1, 2, 3, 1, 5, okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, okay, that should be enough. 1, 2, 3, 4, 5, 6, okay, so 1, 2, 3, 4, 5, 6, 7, 70, yes? So during 6 seconds, I counted 7 beats. So it's meaning that 60 beats per minute. Okay?
Okay. And I'm assuming it's regular sinus rhythm because there's a
Nope. No. The regular, this is, okay, we haven't studied the arrhythmias yet, but the normal sinus rhythm considers that the rate should be between 60 and 100 plus. You should see P wave preceding the QRS complex all the time, and it should be rhythmic. The PR should be equal, but this is not because we do have irregularity. This is not a normal sinus rhythm. And another thing, there is no P wave. So what can be the diagnosis? Arrhythmia, no P wave? No? Anybody?
Maybe an
Atrial
AV block.
fibrillation.
Correct. AFib. That's it. That's it. This is what you should remember. It's very common arrhythmia, type of arrhythmia, and you will face with this one. And you can fail on this one very easily. And but the biggest problem in atrial fibrillation, the coagulation problem. Okay, and the patient can die easily. Now, let's see this atrial fibrillation. So this is not a normal sinus rhythm for sure, but the next time we have arrhythmias. Okay, maybe you do have during the lecture, but we are not doing right now. Okay, good. Axis.
I'm not
Yes.
really sure, but because
One, look at one. One is positive.
yes, and
Good.
also AVF is positive,
Where
so
is
the range
AVF?
is probably between
No,
0
no, no,
to
no. AVF is not positive. AVF is negative. It's more negative than positive. So it's negative. Okay. Yes.
Mhm.
That's positive. That's negative. Okay. What does it mean? Lead number 1 is positive. So you are on the left side. Yes. AVF is negative. So we are again here. This is the left. Okay. Let's look at lead number 2. Lead number 2, that exactly perpendicular to AVL. Okay, exactly. And if it's so, the same, about the same, so that's minus 30. Yes? Please watch again this video and you will understand. But if you are going through the tracing, because we have to go through all the time, so you have time to practice, don't worry. Okay, so this is minus 30, correct? If I say so. Okay.
Sorry, could you just clarify why this isn't a plus 30?
Okay, very simple. Let's look at. Look at lead number 1. Okay, I'm using now a little differently. Okay, that's a yellow. I will draw the leads, okay, the hexaxial system. I will draw it. This is what you should know by heart, basically.
Oh,
okay.
Sorry, the minus 150 I meant, not the plus 30.
My
Okay, apologies.
That's fine. Okay, that's fine. This is AVL. Okay, I writing. This is lead number 1. This is lead number 2. This is AVF. Okay, this is lead number 3. And this is AVR. Okay, good. First of all, we have to look at lead number 1. Lead number 1 is positive, yes? If you do have positivity lead number 1, this is on the left side, yes? Because lead number 1 is negative on the right side. So it has to be on the positive side. Is clear?
Yep.
Okay.
Yep.
So far, so good. Okay, let's go on. Next one, look at AVF. Okay, AVF is positive here. Okay. And negative here. Good. We know that AVF is negative. Okay, we do see it. So this is why it's very simple one to say it, that we are somewhere here. Okay, we are somewhere here. Okay, the next lead that you should look at, lead number 2. Lead number 2 will tell us whether we do have less than minus 30 or more than minus 30. Okay? It's good.
Okay.
Lead number 2 is positive or equiphasic. Doesn't matter which one that you want to choose. If it's equiphasic, it has to be minus 30. If you consider that a little bit positive, you have to come for the minus 20. Okay, so somewhere we are here. Okay. Now, you asked why is not 100 minus 150, because that should be on another side and it's not here. So it cannot be 150.
Plus 150, sorry.
No,
because
because 1 is positive. This is part of the right side, 150 on the right side.
Right. Okay.
So lead number 1 will tell you whether you are between 90 and minus 90, or you are between 90 and 270 or whatever. Okay.
Oh, I see. So if lead one is the one that we look at every time to determine left
Exactly.
right.
This is why we're starting. We are on the left side or right side. That's it. But of course, the most common base, the heart is on the left side. So X is on the left side. This is a very common one. If lead number 1 is negative, immediately you can say it is a right side, let's say pathological right deviation. Immediately you can say it. Doesn't matter too much. Okay. Let's go on. Number 110.
Yes, that's me.
Okay.
So it appears to be rhythmic. There's quite a few blocks on this one. I counted them as 10. So if I divided by 300, that would be 30 beats per minute.
Good, very good. So it's bradycardic. It's very bradycardic one. And another thing that you already had the lecture, there is no connection between P and the QRS complex, because sometimes the P is exactly in the middle of the QRS complexes and the PR interval not constant is getting so that's a 3rd degree AV block. And plus we do have a junctional rhythm, and this is why we have 30. Good. Okay.
Yeah, and I counted the mean electrical axis by the equiphasic approach. So I looked at the lead one because that looks the most equiphasic. And so perpendicular to that would be the AVF. And so since the AVF is pointing upwards, it's positive, it would be plus 90 degrees, and that is normal.
Yes. However, lead number 2 and lead number 3 is not equal. Lead number 2 is bigger, so it's meaning that you shifted a little bit toward lead number 2, so it has to be around 80.
Oh, okay. So
Okay.
is one method not reliable all the time? Should we always
Well,
consider
it doesn't
both of them?
matter. It doesn't mean too much, but if you want to be sure that, okay, what is the normal, well, what kind of axis you have, you can look at some, let's see, the tallest of the R waves, and that's all you can calculate it. But as I said, the ECG gadget will write you immediately the axis.
Okay.
Okay, good.
Okay.
All right, wait a minute. 111. Nobody. Okay. Rhythmic?
No.
Yes.
Well, you are very good because this part is rhythmic. However, here you do see something else. So this is mostly rhythmic, but this is a premature bit that is coming here. But I will assume that is mostly rhythmic. Okay. Now, what is the heart rate? How many squares you have? Let's see. 1, 2, 3, 4, 5. A little bit more than 5. So it means
so around 60 or
55, a little bit less than 60, because if you had 5, that means 60, but you do have more than 5, so it means it's less than 60, so it means about 55, doesn't matter. Okay, so it's bradycardic for sure.
Okay,
okay. Next one, yes, we do have P waves, yes, it's okay, so it can be sinus bradycardia next time. Okay, and axis. Who will do it?
The lead 1 is positive.
Okay, so lead 1 is positive. We are here. Okay, lead 1 is positive. Okay, AVF is
negative. So it's between 0 and negative 90 degrees.
Okay, AVF is negative. So again, we are somewhere here. And what did I say? Which is the next one that you have to look at?
The lead.
Lead number 2, and because exactly perpendicular to AVL, and here this is negative, so the lead number 2 is negative, so we are somewhere here, yes?
Yes.
Now, if you want to narrow down, you should look at AVR. One side of the AVR is 120. Another side of the AVR is minus 60. So by looking at AVR is negative. It meaning that you are located between minus 30 and minus 60, but it's still pathological left deviation. Okay? Understandable?
Yes.
More or less. Okay, good. Okay. 112. Nobody. Okay, let's do together. Rhythmicity.
Regular.
Good. Rate.
There's about 3 boxes in between.
A little bit less than 3 boxes, so you can say that but this is 3 boxes. Okay, so this is 100. Very good. Okay. Next one. We do have P waves. Okay, we do have P waves. So that's a sinus tachycardia. Okay, I can accept it. All right. Axis.
The 1 is negative.
Okay, so we are on the right side. Yes. Okay, and looking at AVF, that's positive. So we are somewhere here. Yes. Looking at AVR, that is perpendicular to 120. Okay. It's meaning that is negative. So we are here between 90 and 120. Yes?
Yeah.
Okay. 13?
Sorry, I think I was supposed to be 112, but I accidentally did 113.
Doesn't matter. Do it.
Okay. It seemed very arrhythmic for the most part. So I tried to take the average of the full chart, and so I counted around 15 beats in 10 seconds. So I multiplied by 6 and got 90 beats per minute.
It could be good. Okay.
Which is pretty high.
Okay.
I checked lead 1 and it was positive. And so I set the starting lead at 0 degrees on the right. And I checked AVF and it was negative. So I knew it was somewhere between 0 and negative 90 degrees.
Let's look at, for example, lead number 1. Lead number 1 is positive, yes?
Yes.
Okay, so we are on the left side, yes?
Yeah.
Okay.
Right side, no?
No, lead number 1 is positive. This is on the left side, okay?
Oh.
Lead number 1 negativity means you are on the right side. Okay. Next one, EVF. You said EVF, where is EVF? EVF, EVF is right here. That's negative. So
Yes.
because AVF is negative, again, you are somewhere here. Okay. You are here between 0 and minus 90. I said, look at lead number 2. Lead number 2 is about equiphasic, yes? So it's meaning that is minus 30. Yes?
Yes.
Okay. Yes?
So if a lead shows an equiphasic QRS complex, that means it's perfectly perpendicular to the lead?
Exactly.
Oh, I see. Okay.
Exactly. Because that means 0. Okay, because the reflection exactly 0 because it's proportional to cosinus alpha. Okay, good. All right. Number 14, 114.
Yeah, here.
Okay.
I meant it was rhythmic, and I counted around 3, but a bit less than 3 boxes between the RR, and
Yes, around 110, 120.
110.
Okay.
And
Okay.
there are P waves present. And for the axes, we can see that lead 1 is negative and AVS is positive. So we can see that it's mostly there's a right axis deviation. And to calculate which side, you have to look at the perpendicular one, which is at we look at the AVR lead. And this is kind of where I'm confused, but it's positive. AVR is positive, which means
a little bit positive. Okay. So it's a little bit more than 120.
Yes.
But doesn't matter. 120 still means extreme right deviation.
Yes.
Okay. Good. Very good. Okay. 115.
It's for me.
Okay.
Okay, so this one is regular rhythmic, and we can see P waves that are present before each QRS complexes. For the heart rate, we have 4 squares, so it must be around 75.
A little bit more than 75 because it's less than 4 square. Okay, it's between 3 and a 4. Okay, it's still normal, but maybe it's 90 or 80 or something like that. Okay.
Okay, got it. And for the X's, lead 1 is positive.
Lead 1?
It's not positive?
No, it's negative.
Because
you have to.
I thought that the upside part maybe it's longer.
No. This is what I said in the leg, because you want to see that during the ventricle activation, how much time the axis is spent toward the electrode or away from the electrode. And you have to summarize it. This is why you have to make a sum of the positivity and the negativity. For example, here, what you do see, it's mostly negative, yes? The sum of
Yeah.
the positive negative. Very similarly here. If I do see here, for example, this kind of, that means positive, okay? Because
Okay.
it's most positive than negative, but you have to summarize it. So that's negative, okay, for sure. So lead number 1 is negative, and again, it's showing that you are on the right side.
Right. Yeah, right
Okay,
deviation.
okay, AVF is positive. Yes, you are somewhere here. And what we said, AVR, okay,
AVR
AVR is
is,
equiphasic. Yes, see, the positivity and negativity are the same.
yeah,
So again, you have 120. Okay,
got it. Got it.
good,
Thanks.
good. All right. 16.
That's me.
Mm-hmm.
So I felt this is a rhythmic
Mm-hmm.
ECG on the top of the graph, yeah. And there is less than a 3 box or maybe around 3 box, so it was
Mm-hmm.
more than 130.
Well, if I say that this is more than 3,
3,
and I think this is more than 3, but close to 3, so it's 100 or maybe
100.
95 or so. So it's okay. So it's
Okay.
all right. So it's
100.
normal. Say it 95. Okay, good.
And the axis is, since the lead one is a
Okay,
positive and
Peter, P wave. Do we have? Yes, we do have P
yes,
wave. The best one to look at the P wave with the chest leads because it's very difficult to see it, especially we do have some different abnormality. Okay, so we do have sinus. Okay, so sinus tachycardia and axis.
and the axis lead one is positive and AVF is negative.
No, 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 no. Now, this is why it's difficult to see it, but this is how the EVF looks like. Yes, this is how it looks like. Now,
Yes,
this is the R wave, so it's meaning the positivity is bigger than the negativity. So I would say that's a positive. This is an
positive.
ST elevation that goes for MI, and we haven't studied, so it's very far from now, but this is a little bit positivity. So it's meaning that 1 and AVF positive, so that should be normal, okay? So it's meaning it's ranging from 0 and 90, so this is where we have. And whether this is which one, lead number 3, look at lead number 3, because lead number 3, okay, is 100, and that should be, it's around, okay, 30, okay? Or if you are looking at AVL, again, you can say that exactly that 60. Let's look at AVL. AVL is positive, so you are somewhere here, yes? Lead number 3 is, I would say, equiphasic one. If it's lead number 3 is equiphasic, you are exactly at 30.
Okay.
Okay?
Okay. Is it cool?
All right. 117.
Hello.
Okay. Listening.
Yeah, so it's irregular. There's definitely an arrhythmia. I counted 8 peaks in the 6 seconds, so that's 80 BPM. The electrical axis, lead one is positive, and then I looked at the AVR and AVL and determined that it would be
Perfect. Okay. Wait. Lead number 1 and AVF. This is the order. AVF is
equiphasic.
okay. So it's meaning that exactly perpendicular to AVF. Yes. So it
Yes.
has to be 0 or 180. Okay. This is a two position can be because lead number 1 is positive. This is 0.
Yeah.
So if you do see a perpendicular lead, that's the easiest one. The easiest one because you can say immediately that's perpendicular, so 90 degree to that one, and especially here in AVF, that should be 0. Now, another lead should not be considered. It's only positive. Lead number 2 is positive, fine. AVR, lead number 3 is, of course, a little bit different one, but by the MI, that is the Q wave is you have here, so that's an abnormal ECG for sure, but this axis is 0. This is how you calculate it, okay? That's simple way.
Okay.
Right? It goes very nice. Okay, so one thing, that's the equiphasic approach. If we do see an equiphasic one, that's an easy one. And here we do see the equiphasic one because that's an AVF. Yes, that's an AVF. Good. What does it mean? It means that we are exactly 90 degrees to this AVF. Okay, this is AVF. How can we 90 degrees? This is, or we do have at 0, or we do have it on 180. All right. So what we have to do, basically, we have to, wait a minute, I cannot choose. Okay, we have to choose. How can we choose? Look at lead number 1, positive or negative. Because if it's positive, that's 0. If it's negative, it's 180. Okay, so let's look at, wait a minute. Okay, good. Look at lead number 1. Lead number 1 is positive. So for sure, you are exactly at 100, 100 and 0. This is what it means, that's 0. Okay? Because 1 was positive, so you are on this side. Okay? Next one, which is equiphasic? Number 2. Good. What does it mean? It's meaning that this equiphasic 2 plus 60, which is equiphasic to 60, minus 30, and 150. How can we choose? By looking at, we can look at lead number 1, doesn't matter. Or you can choose different one, positivity or AVR, doesn't matter. That meaning you are on the left side, and because you are on the left side, it has to be perpendicular to lead number 2, it has to be minus 30. Okay? Okay, that was the quadratic approach that we went through. First of all, by looking at lead number 1, or that can be positive, so we are on the left side, or lead number 1 negative on the right side. And we use AVF, we are down or up. And this is the little table that's summarizing everything. So, for example, lead number 1 positive, AVF positive. Okay, that meaning we do have a normal axis, period, between 60 and 90. Sometimes you don't need to go further because that you cannot use for any other diagnosis because it's a normal range. Okay, let's look at the extreme left deviation. What does it mean? The extreme left deviation means we are between minus 30 and 90. We are on the left side, yes? So 1 has to be positive. EVF should be negative because we are on the top. And the common part of, for sure, is between 0 and 90. And which lead will tell you whether you are here or there? Lead number 2. Lead number 2 has to be negative, and that meaning that you are here between minus 30 and 90. And I said, if you do have EVR, looking at EVR, you can see whether you are here or whether there. Okay. Okay, good. And this meanings very similarly, except that one, that we do have a little bit less than minus 30 or more or forward 0 when 1 should be positive, not negative, but it's positive. Okay. All right. Right deviation, 1 is negative for sure. AVF is positive. We are here. And extreme right deviation, you can see whether the EVR is positive or not. And when EVR is positive and lead number 1 is negative, you can say that's an extreme right deviation. Only right deviation, usually, when you do have 1 positivity and EVR negativity, you are falling between 90 and 120. For sure, the clear-cut value is 100, but it's very difficult to see whether it's 100 or not. But that's right deviation. And what right deviation means? The right deviation means that anatomical situation could explain this deviation. So it's sometimes is normal, sometimes is not. You have to consider the shape of the patient, whether that's a young one, a tall one, that can be falling in this portion. If it's a fat one or short one, it cannot be. So this is how you should approach this. Okay. Quadratic approach. Lead number 1 is negative. Okay. AVF is positive, so that's a right axis deviation. Period. Okay. AVR is equiphasic, so it's 120. Yes? Next one. Lead number 1 is
Positive.
AVF is
Negative.
So what does it mean?
Left axis deviation.
Exactly. Lead number 1 is still positive, so that's only left axis deviation. Okay? That can be normal or sometimes it's not. Okay? Let's look at this one. Lead number 1.
Positive.
Okay. AVF.
Negative.
Okay. Lead number 2 is
Negative.
so that meaning pathological axis deviation because you are less than minus 130. Okay. Now, this is what I summarize it, how you should look at this axis deviation. Look at lead number 1. Lead number 1 telling you whether you are on left side or you are on the right side. That's it, period. Next one that you have to go for, so it's a right deviation, left axis. But left axis can be normal. This is why you can, in the right deviation, let's look at AVR. If AVR is positive, for sure you do have an extreme right deviation, so it's completely abnormal. If AVR is negative, you have right deviation only. Okay? Good. All right. This is how you go. Left axis. Look at AVF. AVF is positive. Very good. That's normal. Okay? Normal axis. If lead number 1 positive, but AVF is negative, for sure that's a left axis. Okay? This is a left axis deviation. But whether this is a abnormal or not, let's look at lead number 2. If lead number 2 is positive, that's you have only left deviation. If lead number 2 is negative, you do have extreme left deviation, so that's pathologic condition. Okay, you can look at AVR to see whether this is over minus 60 or less than minus 60, so whether falling between 30 and 90 or between 60 and 90. Look at AVR. If AVR is positive, you are here. If AVR is negative, you are there. That's it. This is how you can calculate the axis very easily, and I think it won't cause any problem. Okay.